Welcome to DSA with Rashmi. Think, pattern match, and solve. We're gonna solve two problem today, just like yesterday, by following the three steps. The first step is understand the problem thoroughly. Second step is list out the properties and see which data structure will this problem fit in. Third step would be to write an algorithm. Now, let's get started with step 1 to understand the problem thoroughly. Now, let's go through the question. Given a one indexed array of integers numbers, these are numbers. What does one indexed array mean? If usually, how do we index it? Like 0, 1, 2, 3. This is zero indexed array. If we start this by 1, like 1, 2, 3, 4, this is one indexed array. That is all it means. Okay, so we have the numbers here that is already sorted in non-decreasing order. It means that so it's basically sorted and it's in non-decreasing order, means it's in increasing order. See, 2, 7, 11, 15. It's in increasing order. 2, 3, 4, minus 1, 0. It's all in increasing order. We have to find two numbers such that they add up to the specific target. It is the same problem. We need to find two numbers which add to the target. Let these two numbers be numbers index 1 and numbers index 2, where this index 1 and index 2 lies between 1 and numbers of length. They're just saying those two indices will live inside the given array. It won't go out of bound. Now, we have to return the indices of the two numbers, index 1 and index 2. Of course, same like yesterday, will not be actually returning the values that we find, but rather the indices. Okay. Each incremented by 1. Why each incremented by 1? Obviously, right, we are having a one indexed array, not a zero indexed array. If this is 0, 1, 2, 3, if you're doing it like this, while returning, if we find these two numbers, we got to return 0 plus 1, 1 plus 1, which will be 1, comma 2. This will be our output. See? Okay. As an integer. Okay. The tests are generated such that there is exactly one solution. You may not use the same element twice. This we know, as we've discussed in two-sum problem as well, that there cannot be, there cannot be any repetitions of the numbers. You cannot use the same numbers to add to the target. That is one thing. Here the tests are generated such that there is exactly one solution, meaning you will definitely have one output. There can't be zero output or multiple output. There will only be one output. Your solution must use only constant extra spaces. Um, so, like in previous problem, like in two sum, we used an extra map, right? We use an extra map. So therefore our space was big O of n. We use extra space. They're specifically mentioning that over here, that we cannot use an extra space. Okay. Now that we've theoretically understood the question, let's move to understand the problem. Same thing like we did yesterday. Example 1 would be number nums 2, 7, 11, 15. Target is 9. So we'll be adding 2 plus 7, 9, which matches the target. So what we gonna do? This is 0, 1, 2, 3. We need to return. So these two we have to return. 0 plus 1, 1 plus 1, 1 comma 2. That's the output. Now example 2, we have num 2, 3, 4. The target we have to match is 6. Let's see. We add 2 plus 3, 5, which is not same as the target. Then we add 2 plus 4, 4, 5, 6, same as the target. This would be 0, 1, 2. Now I'm going to return what this and this. So 0 plus 1, 2 plus 1, 3. This is what I'll be returning. Correct, right? Okay. Now example 3, we have nums as minus 1 comma 0, and the target that I want to reach is minus 1. I'll add minus 1 plus 0, which is minus 1. I found my target. 0, 1. So I'm going to return 1 comma 2. Okay. Now that we've understood the problem, clearly, let's move to the next step. That is, we'll have to list out the properties and check which data structure fits in over here. As we've already discussed, for those who have not watched my previous video, as I've already discussed, you can go back and watch to some if you'd like before coming here. We've already discussed that whenever you see properties like two sum or pairs or sum equals target, always this should just come to your mind. These following data structures could fit in. We could use like hash map. If there is a necessity of fast lookup, we might need hash map, or in this case our array is also sorted. We have a sorted array, and then so whenever you see that the array is sorted, there is possibilities that you can use two pointer. Okay, now that we've somewhat established that the array is sorted and we can use two pointer, let's move on to working towards the algorithm. I'll again write my examples over here so it gets easier for me to work with my algorithm. I'll call it array 2, 7, 11, 15, and I want to reach a target that is 9. Okay, now I'm just thinking, since we have to use a two pointer approach, I will have two pointers. Okay, I and j. I will make I start from here, first value, and j start from here. Okay, now what I'll do, I'll calculate the sum of both the values of I and j. Sum is going to be array of I plus array of j. Okay, now let's calculate what is array of I, 2. Plus what array of j, 15. What is the sum? 15 plus 2, 17. What do we see here? What's happening is basically the sum is greater than our target. So what do you make out of this? So what's happening is sum is greater than target. So in order to reach the target, in order for our sum to become the same as our target, our sum needs to be decreased, right? It has to be decreased. How can you decrease the sum? How can you decrease the sum? So you need to decrement j. What? I'll tell you again. So you basically want your j to be decremented and it should move here. Think about it. So instead of, if anybody has questions like why do you need to decrement j or and not increment I, think about it. If you increment I, it means that this is a sorted non-decreasing array. So as you go towards your right, the values keep increasing, and as you move towards your left, values keep decreasing. You see that, right? So that is why if the sum is greater than target, in order for your sum to be same as the target, you need to decrease j. Okay, let's write that condition. If sum is greater than target, I will do minus minus j. Okay, now suppose, or let's have one more condition. Else if if my sum is lesser than target, let's say the sum that we've found, don't take this example, let the sum that we found is, let's say, 7. So this is sum. What in this case, sum is lesser than the target, which is 9, right? So I want to move my j to, I want to increment my j. That way, we know for sure that our sum will increase, and somewhere it might, some at some time it might reach my target. That is why we increment I. Okay, I plus plus. Now the last condition is, uh, else, let's make this if only. If my sum is same as target, I want to return I and j. I just want to return I and j, the values 0, 1, 2, 3. But not exactly I and j, but rather I plus 1 and j plus 1. Why? Because, where is that? One index array, because of one index array, and they've exactly told, where is that return? Return the indices of two numbers, each incremented by 1. That is why. Okay, fine. Now, the last condition we need to put in. We need to put this inside a loop, right? Till, till we exhaust this array. So what condition do we put? Imagine I keeps incrementing, j keeps decreasing. There could be a situation where, there could where this, suppose, what if there could be a situation where I come here and j would come here. That means there is no more comparisons left, right? So till how long you need to run this? As long as while I is less than j, run the loop. This is our algorithm. Now that we finish writing our algorithm, let's look at our algorithm and write our code. So we need to initialize two variables I and j. I starts with 0 and j, remember j was starting at the last index. So I'll declare let I equal to 0, let j equal to numbers dot length minus 1, and then I need to have a while loop while I less than j. While I less than j, I need to calculate sum. Let sum equals array of I plus array of j. If sum is greater than my target, then I'll decrement j. If sum is greater than target, then I do minus minus j. Next condition would be else if sum is less than target. Remember, we were incrementing I. Last condition, else, meaning both sum and target. Sum is same as target now. I'm going to return I plus 1 and j plus 1. If none of the condition matches, I'm just going to, return minus 1. Let's run the code and see. Okay, I have this problem. Numbers, numbers. Yeah, I guess it should be fine now. It's not a valid return type. Okay, let's just wrap this up in an array. Okay, it runs. Let's submit and see. And it works. Finally, let's just talk about the time complexity and the space complexity over here. We're not using any extra space, so the space complexity is going to be big O of 1. We've achieved that as requested in the question, And since we're using a while loop, it is going to iterate through the entire array into the given entire array. So the time complexity is going to be big O of n.